An ambulance races toward you, siren screaming. And as it passes, you hear it, that unmistakable drop. Neum. On the way toward you, the pitch is high. The instant it passes and starts moving away, the pitch falls. Here is the strange part. The siren itself never changed. The driver did not touch a dial. The sound coming out of that speaker is exactly the same pitch the entire time. The change you hear is created entirely by motion, by the ambulance moving through the very sound it is making. This is the Doppler effect, and it is one of those rare ideas that starts with something you have heard 1,000 times on the street, and ends up being the tool we use to discover that the entire universe is flying apart. The same physics behind a passing siren is how we know about the Big Bang. Let's see how a changing pitch leads all the way to the edge of everything. To understand it, we have to picture sound as what it really is: waves. When a speaker makes a tone, it pushes out ripples of pressure through the air, spreading outward in all directions, exactly like the rings that spread when you drop a stone in a pond. Each ring is one wave, and the pitch you hear depends on how often those waves arrive at your ear. Waves pack close together, arriving rapidly, sound high. Waves spread far apart, arriving slowly, sound low. Now imagine the source sitting perfectly still. The rings spread out evenly in every direction, like a perfect bullseye. Someone standing to the left and someone standing to the right receive the waves at exactly the same rate. Everyone, all around, hears the identical pitch. As long as nothing is moving, the sound is the same in every direction. The magic only begins when the source starts to move. So now let the source move, say to the right. Here's the key. Each new wave still spreads out from the exact spot where it was created. But by the time the next wave is born, the source has already crept forward a little. So each ring is emitted from a point slightly ahead of the last one. Look at what that does. In front of the moving source, the rings get squashed together. Each new wave crowds up against the one before it, because the source is chasing its own sound. The waves are packed tight, and behind the source, the rings stretch apart. The source is racing away from them, leaving extra space between each ring. Now place our two listeners. The one in front, where the waves are bunched up, receives them rapidly, high pitch. The one behind, where the waves are stretched out, receives them slowly, low pitch. The ambulance approaching you is sending you the squashed waves. The instant it passes, you fall behind it, into the stretched ones. That sudden switch, from crowded waves to spread out waves, is the drop you hear. And now the leap that changes everything. Because sound is not the only thing that travels in waves. Light does too. And light obeys the very same Doppler rule. With light, the pitch we call frequency shows up as color. Squashed light waves, crowded together, shift toward the blue end of the spectrum. Stretched light waves, spread apart, shift toward the red end. So if something glowing races toward you, its light gets very slightly bluer. If it races away from you, its light gets very slightly redder. We call these blue shift and red shift. On Earth, the effect is far too tiny to see with your eyes. Cars and planes are nowhere near fast enough to change their color. But point a sensitive enough instrument at something moving fast enough, and the shift becomes unmistakable. And there is one place absolutely full of things glowing and moving at staggering speeds: the night sky. In the 1920s, astronomers began carefully measuring the light from distant galaxies, splitting it apart to read its colors. And they found something deeply strange. Almost every galaxy they looked at was redshifted. Its light was stretched, shifted toward red, which by the Doppler effect meant one thing. Those galaxies were moving away from us. Not a few of them. Nearly all of them, in every direction we looked. But the truly shocking discovery came from a man named Edwin Hubble, who noticed a pattern in the amount of redshift. The farther away a galaxy was, the more its light was stretched, and so the faster it was rushing away. Double the distance, and a galaxy flees twice as fast. The whole sky was a chorus of redshifted light, every distant galaxy racing from us, and the most distant ones racing fastest of all. At first, that sounds like we are at the center of some great cosmic explosion, with everything fleeing from us. But the truth is stranger and far more beautiful. It is not that galaxies are flying away through space. It is that space itself is stretching, swelling in every direction, carrying the galaxies along with it like raisins in a loaf of rising bread. Every raisin sees every other raisin moving away. There is no center. The universe is expanding. And once you know the universe is getting bigger, you can run the film backward. If everything is spreading apart today, then yesterday it was closer together, and long ago it was unimaginably dense and hot, all of existence packed into a single point, until it began to expand. We call that beginning the Big Bang, and we know it happened, in large part, because of stretched out light. The same effect that drops the pitch of a passing siren, written across the whole sky, is what revealed the birth of the universe. So the next time an ambulance tears past you and its pitch dips down, listen closely, because you are hearing the same physics that uncovered the beginning of time. The Doppler effect is in the speed gun that clocks a car, the radar that tracks a storm, the instruments that find planets around distant stars by the faint wobble in their light. It is a single, simple idea. That motion squashes and stretches the waves a thing gives off, and it reaches from the street corner all the way to the edge of the cosmos. A changing siren and an expanding universe are not two different mysteries. They are the very same one, just heard at different scales. That is the quiet thrill of physics. The rules that govern the smallest everyday moments turn out to be the exact same rules that run the whole universe. This has been Actually Rendered, where we show you how things actually work. If this made the ordinary feel a little more cosmic, you know which button to press.